Hello everybody and welcome to this week's Easy 11 Plus live lesson, this time on the thrilling topic of 3D shapes. And I'm sure you've all seen me in the cover image dressed in a big cone. Oh, the comments are starting to come in. Guess who it is? It's Strawberry Clouds wanting a shout out. Every week, goodness me, how keen for attention are you? Vamika says, you guys, please stop asking for shout-outs. Yeah, I'm not going to give so many shout-outs because it just takes up loads of time and it's not that interesting. I know you exist, you know that you exist. Hello, Mr. Tony Cotton, who has said hello without asking for a shout-out, and so I'm saying hello to you. Right, new policy, I might say hello to people who don't ask for shout-outs. How's that? Ooh. Right, okay, fantastic to have you here. One really quick bit of news before I get going. If you know anything about my 11 Plus Lifeline service, link below, I'm now doing a new thing with that where people who are members on the level that gets you feedback on your work, I'm now actually giving voice feedback in even little videos where I explain what to improve in people's work. So if you think that personal touch is something that might be useful, have a look at 11 Plus Lifeline down there. But also I've released a video about my new voice marking, and I'll put that in one of the comments underneath this video. Right, enough of all that. Let's get started with the lesson. So I'm sure you've all seen the worksheet. If you don't know how these lessons work, the worksheet is always linked in the video description underneath the video. And if you're on my mailing list, then you actually get the worksheet a few days in advance. And I also share it on Facebook and that kind of thing. If you haven't seen the worksheet yet, that's where it is. It's linked in the video description. You can print it out, download it, pin it to your bedroom wall, throw paint at it, whatever you like to do with interesting worksheets. Anyway, 3D shapes. The reason I'm covering this is because loads of people have asked for it. So if you want me to cover a topic, ask. Because when people ask for a topic, if it's relevant, I write it on my list and at some point I cover it. Hello everybody saying hello. Hello Seema Music UK. Really good to hear from you. Hello Science Stalker. Jedi saying, can we get on? Who are these people who think they can come into the lesson and just start ordering me around? How rude are you all? Anyway, I'm very rude by the look of things. Right, okay, here we have a 3D shape. Which name best describes the following 3D shape? Okay, in this lesson I'm going through exam questions. I'm not going to cover everything from the ground up, so I'm not going to tell you about every kind of shape. If you want to learn that, go to your school books. But this is a good starting point. So this is, what is this? Well, is it a pyramid? What's a pyramid going to be? Well, you know that a pyramid, of course, is kind of like, oh, can I draw in 3D? Yeah, sort of. That's a pyramid. Okay. Other shapes that are similar to a pyramid. So you might have a cone. Okay. 3D shape, but rounded. Okay. But this is neither of those things. Now, what is this? Now this is that classic of the 11 Plus exam, an unfair question, or a question with no clear solution. So, what is a prism? Has anyone written in the comments yet what a prism is? Someone has written pentagonal prism, so someone's really firing on all guns today. Has anyone said what a prism is? I haven't asked, so you know, it's not that you should have done. Lots of people saying prism. No one said, someone's writing great drawings. I think they might be lying to me. What a prism is. Right, prism. Oh, hang on, someone's writing. Ash A. A solid geometric figure whose two arms are similar, equal, and parallel rectilinear figures and whose sides are parallelograms. You definitely pulled that out of your own head, didn't you? Yeah, so a prism, in simpler language, is something that you can slice it all the way through and you'll get the same thing, basically. Is what it comes down to. So this is clearly supposed to be as someone said, pentagonal prism. It's a pentagon at the end, and it's the same pentagon all the way back to the far end. Slice, 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 slice. Now there's a bit of a problem with this, which is that it's very, very badly drawn. You can clearly see that this distance here is actually greater than this distance here. Now if it was drawn for perspective, at the back there it would actually be narrower, or if it was just drawn kind of, I don't know how to put it kind of schematically, it might be the same, but there's no way it could be wider and this be a prism. So to be really, really picky, if we really zoom in here, that's not actually a prism, but it's clearly supposed to be a prism. It's a really badly drawn prism. So pedantic answer would be neither of these. The answer that would actually get the mark in an 11 plus exam is prism. Okay? So it's a horrible question. It's useful to talk about because it's just a bit of exam common sense. If you have to say neither of these, you really have to write next to it because it is taller at the back or something. Because otherwise the examiner will just go wrong. Okay? The answer they're looking for is clearly prism. Right. A prism is a cow, just like Joe Mama. That is one of the more enigmatic comments that I've seen here. Touch of the Eric Cantonars. Anyway, a cube has each of its faces covered by one face of an identical cube, making the solid shape shown. Okay, this thing people refer to word questions, which, I mean, apart from questions with no words, doesn't really make much sense because all words are word questions. But I see something like this and I sort of know what you mean because it's really wordy and you have to work out what it's getting at. So a cube has each of its faces, you know what a face is, it's the flat bit like that, has each of its faces covered by one face of an identical cube. Okay, so each face of a cube has got another cube stuck to it, face to face, and that makes the shape shown. Okay, the shape shown. So if every face of that cube has got a cube stuck to it, we must be talking about the cube that's hidden in the middle, the one that we actually can't see here because it's hidden by all the other cubes. So that tells us that this is a solid figure without any space inside it. There's a cube in the middle. Okay, so there's a cube in the middle and there are these cubes around the outside. How many are there? There's one on the top, one on the bottom, one at the back, one at the front, one at the back, one at the front. So that is 1, 2, 3, 4, 5, 6, and there's one in the middle, so there were 7 cubes in total. Now, the first question doesn't say how many cubes are there. I haven't even looked at the first question, but I know that knowing how many there are is going to be essential for anything I do with this figure. So it's worth working that out as a starting point. What's the volume of one of the cubes? Well, we know the volume of the solid shape as a whole is 875 centimetres cubed. So the volume of one of the cubes, well, this is easy maths, isn't it? It's 875 divided into 7 bits. Why is it divided into 7? Because we know that all these cubes, each of these cubes has the same volume. Why do we know that? Because we're told that they are identical cubes. Okay, so make sure you go through the details in the question. Indeed, well done to Vamika, who said I think we should do 875 divided by 5. That is absolutely what we should do. Some people are posting an answer. We've got different answers here. Great, okay. Nadia says 135 centimetres cubed. Ibrahim says 125 centimetres. Ibrahim, what have you forgotten? Let's find out. Right, so 875 divided into 7 cubes. So the total volume, what is it for each cube? So 7 goes into 8 once. We've got 1 left over. 8 goes into 17 twice. 2 7s, 14. So we've got 3 to carry over. And 7 goes into 35 5 times. Okay, you need to know your times tables to do these things. Is someone commenting yet? Please someone comment. Please someone comment. Please somebody comment. No, you're not going to let me get away with this, are you? You really are. That's not a 4. 7 doesn't go into 17 4 times. It goes in twice. There we are. Okay. So careful of that kind of thing, where you can do something like say, well, 2 7s are 14, and then because you've got 4 in your head, you write 4. That's why you need to just check back your working, do the kind of common sense check to make sure that you haven't done anything stupid. Finally, someone's commenting I made a mistake, but you didn't comment on it until I'd already pointed it out. What's going on, people? Right, 125. So whoever said that was right, but whoever said 125 centimetres was wrong because it's 125 centimetres cubed. This is a volume question. People, it is not a length or distance question. You get away with it here because they give you the centimetres cubed in the answer space. Often they won't. Often you'll have to write the units, and if you'd written centimetres rather than centimetres cubed, you would have, oh yes, lost a mark. Don't do that. What is the length of one side of a cube? Okay, how can you work that out? What do we know about the properties of cubes? Okay, here's a cube. Beautiful cube. Someone complimented my drawing earlier. You're going to love this one. How is this for a bit of drawing? Serious lesson here, by the way. When you sketch, don't waste time doing it perfectly. Just sketch as accurately as you need to do what you need to do. And any more accurate than that is a waste of time. Right, so here you've got a cube. We know that a cube, that this and this and this are all the same length. Okay? So how do we find the volume of a cube? We take length A and length B and length C and we times them together. So A times B times C gives us the volume, right? You know that. And we also know A, B, and C are the same. So actually A times A times A equals volume, and that's actually can be written as A cubed. It's a cube. It's unsurprising. You know this stuff, but just quick revision, you know? Okay, so how do we find the length of one side of a cube? Well, what have we got going here? We know that A times A, let's write it like this because it's easiest to visualize rather than A cubed, is 125, okay. So what is A? And I think from this stage, you're just going to be doing trial and improvement. So let's say that A was 2. 2 times 2 times 2, 2 times 2 is 4 times 2, is 8. So if A was 2, that would be 8, not 125. That would be way too small, okay? Let's go for something much bigger. What if A is 10? 10 times 10, it says 100 times 10 is 1,000. So hang on. If the length of a side of our cube is 2 centimeters, then the volume is 8 centimeters cubed. If the length of a side is 10 centimeters, the volume is 1,000 centimeters cubed. Okay, that is how big, how quickly cube numbers go up. Really quickly. It's going to be something in between. Okay, it's nearer to 2 than to 10. What other number is really easy to work with? 4. 4 times 4 is 16, times 4 is 64. Too small. 5. 5 times 5 is 25, times 5 is 125. Okay, it's 5. 5 centimeters, because we're talking about a length, not centimeters squared, not centimeters cubed. Now, you didn't need to go through all that because you can see that this ends with a 5. Two things at times together to make something ending in a 5. Probably at least one of them is going to end in 5, right? So it's probably a 5 involved. So you're going to start trying 5, 25, 15, that kind of thing, rather than messing around with 2s and 4s and all that nonsense. So yeah. Anyway, great. Well done, everybody. You got 5, which I can see from the comments is a lot of people. Prashant Patil in the comments says, what is volume? That's actually a really good session. It's a good question. It's quite difficult to define. Volume is the amount of stuff inside something. So let's say that a centimeter cubed is a sugar cube. Okay, I haven't got one on hand to show you, but let's imagine a sugar cube. So a volume problem might be how many sugar cubes can you fit inside the thing? And that's a way of thinking of the volume. Volume goes very closely in hand with capacity. We might think about what's the capacity of a container. We'd normally be thinking in liquid measurements. So if we said how many milliliters fit into this thing, then we'd be thinking, well, how much water or some other liquid can I pour into it to completely fill it up? And a milliliter takes up the same amount of space as a centimeter cubed. Okay, so that's another way of thinking about it. This is what volume is. It's the amount of space inside something, basically. Robert, did you make a vid showing how to find volume? You, for 11 plus, don't need to know a great deal about how to find volume. You need to know how to find the volume of a cube, like this, which is, come on, you know that. You need to know how to find the volume of a cuboid. You know that too. We'll come to that. Don't really need to know much else. Anything else you're going to be told. Like, how do you find the volume of a prism? It's actually really simple. So let's go back to our prism. You find the area of the end shape, whatever that shape is, and then you times it by the depth. Okay, so that's really simple. But I don't think they'd expect you to know that. You'd be told, and anything else like a cone or whatever, if you theoretically, there's no way they'd want you to find the volume of a cone. No, not a chance. You don't really need to know much about finding volumes, people. It's going to be cubes and cuboids all the way. Areas is what you need to worry about. Can you find the area of a triangle, for example? Which 3D shape does the net below make? Okay, sip of coffee. Let's share this coffee moment. You can just imagine how satisfying that is. Tip of the week, don't become dependent on coffee. Okay, which 3D shape does the net below make? Right, what 3D shape does it make? I think you can probably see this, but let's, how can I kind of feel it's so obvious that I'm thinking, how do I explain it to, I should have done this thinking beforehand. How do I explain this to someone for whom it isn't obvious? Let's imagine a base, okay? So let's pick a face to be the bottom. So let's imagine that this is the bottom of our shape, whatever our shape is, okay? It's nice to see that when people are copying and pasting definitions of things that they found online, not naming any names, Mr. or Mrs. Strawberry Clouds, that they're pretty much saying what I said. Okay, let's imagine this is the bottom of it, okay? So that's the bottom of our shape. And then we're going to fold up this and this to be sides. Bum, 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 bum. You've clearly got a box, okay? And then this is going to fold onto the top, and it's still going to be a box. A box, what is the mathematical name for a box? Unless you've got a very peculiar box, it's a drum roll. Thank you to almost everybody in the comments. It's a cuboid. So a cuboid is basically a rectangular cube, is the way to think about it. That's not very mathematically defined, but it makes it easy. And if you want to remember that a cube, it's a cube. It's precisely a cube. All the sides are the same length. Oid, it kind of means sort of kind of, like a humanoid is something that has a human shape in science fiction books or films. Kind of human shaped, but not quite human. Cuboid is kind of a bit cubey, but not quite a cube, because the sides are different lengths, okay? They don't need to all be different lengths, but at least one side length is different. Yeah, so it's a cuboid. Let's cross out all my scribblings. I've made them so messy. Why couldn't I have done them all in the same direction, people? What shape does it make? It makes a cuboid. I said to myself, I'm going to finish this lesson a bit more quickly than last week. Let's see whether I can still do that, even though I'm waffling a bit. It's a cuboid. Try to write more clearly than me. I do have the excuse I'm trying to write on this sort of glass screen, which is a bit tricky. And also if I rest my wrist on it, it pulls it around, so I'm trying to write in midair. Okay, enough excuses. Right, so work out the volume of the 3D shape. How do you find the volume of a cuboid? You know this, but let's sketch it anyway. How do you sketch a cuboid? You sketch it like this. You just sketch a rectangle, and then you sketch the sides going back, try to get the same direction pretty much and the same length pretty much, and then we sketch the back here. If you want to make it sort of a kind of more 3D sketch, you can kind of shade in one of the sides a lot and one of the sides a bit, but don't do that now because you want to be able to fill in with labels, and shading will make it harder to label. So we're going to start filling this in. We've got a length that's 8 centimeters. I'm not going to write centimeters on my diagram to keep it nice and clean, but I need to remember them when I write any answers. Okay, so the length is 8, and then the kind of the depth of the base, if we think about this as the base, is 6, so that's there, also here, also here. And then we've got 4, which is on the side that folds up. It's the height. Of course it's the height because that's all we got left. So we got 8 width or length, you could call it, 6 depth, and 4 height. And you know how you find the volume of a cuboid. Someone wanted to know how you find volume. This is how you do it. You just do those 3 things times together. Of course, in any order, because multiplication is... Can someone write this word in the comments in the next few seconds? Multiplication is... Drum roll. Come on, someone write the word, someone write the word. 10, 9, 8, 7, 6, 5, 4, yes! Aika Yadav. Fantastic. You're in there. Commutative. It is. Right, Alka Yadav. You, unknown to you until this moment, are the proud winner of the very first piece of Easy 11 Plus merch to be distributed. Because I don't have any with me to show you right now, but there is now a range of Easy 11 Plus pens and pencil cases, and that earns a pen. So if you would kindly get in touch by going to the RSL Educational website and getting in touch through the comment box, I will make sure that you are sent an Easy 11 Plus pen for getting the answer to that first. So that's for Alka Yadav. Well done. Right. Okay. Someone says I should teach art. Definitely using an pen. Okay, your name is Isha. So Isha Yadav. Fantastic. Well done. Get in touch with your address and I will make sure that you get the pen. Right. So 8 times 6 times 4, which could also be 8 times 4 times 6, could be 4 times 6 times 8, and so on. Okay, you can do multiplication in any order. It really doesn't matter. So you don't need to remember width times depth times height. You just need to remember multiply the lengths together. That's it. 8 times 6 times 4. Right, let's do this as easily as we can. What's 8 times 6? We could do a multiplication. Let's try and do this mentally and see what happens, okay? So, how do we do 8 times 6? I think the easiest way to do this is, well, no. You really should know your times tables, to be honest. Yeah, you should know this. 48, okay? Okay, and how do you do 48 times 4? So, if you have any doubt whatsoever, do not do it mentally, right? 48 times 4 and work it out. It is not going to take you long at all. But let's just do it mentally as a little bit of an exercise. How would you do 48 times 4? I think the easiest way is to say that 48 is right next to 50, and 50 times 4 is 200. 48 is 2 less, times it by 4, we're going to be 8 less, so we're going to end up at 192. Okay? Check that here if you want to be sure of it. If you have any doubts at all about the method of doing it mentally, if there's even the slightest possibility you might get it wrong, then do it up here, okay? So you do 8 times, what are we doing here? 8 times 4, you'd have 32. 4 times 4 is 16, plus 3 is 19, okay? So you'd end up there. 192 centimeters cubed. I have to check to make sure they've given the units. They have, so I don't need to write them in, and so I don't lose half a mark. I think I would lose if I didn't put units had they not provided them. Okay. Okay, right. When a 3D shape is constructed, which two other vertices meet up with the vertex labelled with a star. Okay. Whoa, lot of words there. What does... Oh, shouldn't show. I just showed it on the screen. There we are. What does the word vertex and the plural vertices mean? Well, if you're not sure, look at the picture and see if you can work it out. So the vertex labelled with a star, that's down there. So what's a vertex? It's a corner point, okay? That's a vertex. You should know that, it's important terminology. And the plural is vertices. Right, vertex and vertices, anyway. Here we are. Which other vertices meet up with it? And if that's puzzling for you, think about what's going on. This is a net, right? It's the folded out cereal box. And when it's folded into a 3D shape, each corner meets another corner. So you can see that this here, for example, is going to meet with that. That's an easy one. What's this going to meet with? I think the easiest way to do this is to look at our sketch over here. And I really recommend sketching to get a clear sense. So this is the base, right? So that's underneath. Let's follow these points round. So if this is the side that folds up here, this is going to fold up to be just up there, so that's going to be this vertex here. And this is going to be the top piece, it's going to fold over the top, and so this corner is going to end up here. So this here is going to meet this and something round, so it's going to meet this and that round the back there, okay? So what's this here? This is the end piece. The end piece is this piece here. Ooh, squiggly squiggly. We're talking about this here. Right, and what's going to be that corner? That's going to be, this is going to fold up to be on top. So we're talking about this here. Right, I have to mark with my star and not have all this rubbish on. If you're going to scribble rubbish, always make sure you do it in pencil so you can get rid of it. Don't scribble rubbish in pen. So that is going to be one of the points that meets this, okay? And this here, this arrow pointing towards the back there, is going to be the back piece that folds up the back, okay? That's clearly this piece here. And this corner here is going to be the one that comes up and meets this corner here. So, things I did there that are important. I sketched the cuboid, so I had a visual reference for what the shape is going to look like when it's 3D. I made absolutely sure to pin down which piece, in my mind, is the bottom piece, and I chose this here. Now, really important thing, you could choose any of, you could choose any of these 4 faces as the bottom face, okay? If you sketch it this way around, and you could do it on its end, and then you could choose this or this as the bottom piece. It does not matter which face you choose as the bottom face of your cuboid, as long as you're consistent. You're still going to end up with the same corners on the net meeting. Right, super. Okay. People, I don't know what you're arguing about in the comments, but please don't. It's just nasty and pointless. Don't come here to do that. Right. When the 3D shape is constructed, which turns... Oh, we've done that. That's what we just did. Okay, done. Good. Onwards. Aha, right. A cube has 8 vertices, corners. There we are. Definition of what we were just talking about. Coffee moment. 6 faces and 12 edges. All right. 8 vertices, 6 faces, and 12 edges. How many vertices, faces, and edges does the L shape have? People, read the question carefully. Do not make the mistake of working all these things out for the cube again and writing those in the answer space. You are given that information already. You do not need to work these things out for the cube. We are looking at this thing down here.